Okay, so again, two equations, both with denominators. Find a common denominator for each equation and multiply both sides by that. So we're going to get xy times 3 over x minus xy times 5 over y plus xy times 3 equals 0. And we're going to get denominator here is the same, and it won't always be that way, but in this case that's what we have. So we have xy times 4 over x minus xy times 2 over y minus xy times 5 equals 0. And now we simplify. The x's divide out, we end up with 3y. The y's divide out, so we end up with minus 5x. And then we have plus 3xy equals 0. Here, xy times 4 over x, the x's divide out, we end up with 4y. Here we end up with minus 2x. And here we end up with minus 5xy. That equals 0. Okay? Now, we have a couple of choices. If we want to solve, and let's see, something's wrong here. This should be an x. Yeah. Okay. If we try to solve this equation for y, we're going to get y equals some multiple of x, but then times, well, actually to solve for y, we'd have to factor y out of these two terms. And we get y times the quantity 4 minus x. And that would equal 2x, so that y would equal 4 minus x divided by 2x. Plugging that into the first equation, or into even this equation, we're going to end up with denominators again. And we could do it, just do the algebra carefully, but conveniently we could add multiples of these equations to eliminate xy. Okay? So I'm going to say we choose xy terms. We multiply 5 times the first equation and 3 times the second equation, and that's going to give us a 15xy here and a negative 15xy here. So we can write that out. We got 15y minus 25x plus 15xy equals 0. And, try to be careful, 12y minus 6x minus 15xy equals 0. So now we have 27y minus 31x equals 0. Just adding these two. And now we have an equation where we can solve, let's say, for y in terms of x. Okay, so y is 31 over 27 times x. We can take that, plug it into, we could plug it back in here, but then we'd have denominators and have to go through that whole thing again, assuming that we've multiplied correctly here. And of course, if we haven't, we're messed up anyway. We can plug in, let's say, here. Okay? And here is a little more convenient than here, because you multiply 3 by 31/27, the 3 goes into the 27. If you multiplied 4 by 31/27, you wouldn't have that. Okay? So we're going to choose to plug it in here. So now, I need a reference. I don't want to use arrows. So I'll say we'll plug it into equation A down here, calling this equation A. We get this. Okay? And this is going to give us an x squared term. We're getting a quadratic again. And most of these equations are going to end up with a quadratic. So we end up with think before writing. 3 goes into 27 9 times. We end up with 31 over 3, 31 over 9, x squared. And then we have a minus 5x, and we have a, again, 31 over 9, x. So that's 31 over 9 minus 45 over 9. And these equations usually won't get quite this messy. Your book is a little nicer than I am. And with just plain old luck, it looks like we've got a quadratic that can easily be factored by factoring out the x. So x would either be 0, or setting this equal to 0, it's pretty easy to solve. You get 14 over 31. Now, x equals 0 is not a possible solution, because your original equation had x in the denominator. And you can't have a 0 in the denominator. You can't divide by 0. So x equals 14 over 31 is the only solution. And you plug that in. And you can plug it into these equations. Now let me just say, when I multiply by xy here, I really should have been careful to say and I don't have a good place to write it, so I'm going to write it in a bad place. X can't be 0, y can't be 0. Because if either one was 0, I'd be multiplying my original equation by 0, which would just give me 0 equals 0, even though it doesn't look like it. If x or y was 0, this wouldn't work. Okay, so anyhow, we end up with x equals 14 over 31. And we can plug that into either of these equations. So again, when we got x equals 0, by looking back at the original equation, we see that can't be done. But if we had written this restriction here, we'd be doubly sure to notice that x equals 0 can't be part of the solution. Okay? So now we just plug this in to either of these equations and solve for y. So we can plug into equation A. We get 3y minus 5x plus 3x times 14 over 31 if I had plugged in for x, I'd have gotten it right. I'm writing things down very badly today. Okay, 3y minus 5x, which would be 5 times 14 over 31, and then plus 3xy equals 0. Well, this is 42 over 31y. This is 3y. You can add those, put this over on the right hand side, and solve for y. I'm out of room, so I'm going to say etc. Solve for y. The main thing that we want to see here is simply that when you have the denominators, you multiply by them. Depending on how you handle these two equations, you could end up with a quadratic. But in this case, you can actually eliminate x and y. The xy term, I'm sorry. And then get y as a multiple of x and proceed. If you do it a little differently, you could end up with the quadratic. So just to show you, in case that becomes an issue, when we got down to these equations, our alternative would have been to solve the first equation for x or y. I'll choose to solve it for y. And you get write it this way, y times 3 plus 3x minus 5x equals 0. Combining this term and this term, we factor out the y, and we get the 3 plus the 3x. So that y equals, skipping a step here, but it's a pretty obvious step, 5x over 3 plus 3x, and we could use it this way, but since the 3 is common to the denominator, we could write this as 5/3 times x over x plus 1, which might or might not be a little easier to deal with when we get up here.
As well?
I'm sorry.
Shouldn't it be a negative?
Well, no, because we had a negative here. If we add this to both sides, it's going to be positive on this side. Okay? It's the first time I was ever right when you ask me a question. Which reflects well on you, but I actually, it's nice for me to be right once in a while. So I feel pretty good, but I feel sorry for you. No, okay, good question, but in a rare instance I was right. Okay, in the first place. Okay, so y equals this. So now we plug this into the second equation. So it gives us 4y, which is 4 times 5/3 times x over x plus 1 minus 2x minus 5 times 5/3 times x over x plus 1 times x equals 0. Now again, to see this, you have the x, you're plugging in for y, so you're going to get the y here, but then you have times x. I could have put the x out in front, probably would have been better if I had. Okay? Well, we have a common denominator here of 3 times quantity x plus 1, right? So we multiply by that, and we get what? We get 4 times 5 times x, which is 20x. Multiplying this, we get minus 2 times 3 times x plus 1. And here, again, the denominator is going to go away. We're going to get 25x squared. And that's going to be equal to 0. So we get negative 25x squared And then we get 20x here, and we get negative 6x here. So that would be minus 14x. Yeah, minus 14x. And then we get a minus 6 here.
Now, Professor,
Yes.
did we lose an x in the term 2x, multiplying it by the common denominator?
Yeah, and I'm glad you pointed that out because this thing wasn't going to work out. Again, see, you're up to 99%, which is lower than your course average. Well, maybe it's a little higher, but you can have a high course average. So. And if I was giving extra credit, you'd have that. Okay, let's see. Now, yeah, let's get rid of this because I didn't like it anyway. And I did lose the x. I don't have a good place to write the x, so I'm going to get rid of this too. Okay, so it's minus 2x times 3 times x plus 1. Now, that gives us negative 25x squared. And, well, actually here we've got a minus 6x squared, right? So I guess we have minus 31x squared. Okay, hopefully we've done this right. And there's the 31, and that's convenient because remember we had 31 over here and in our solution previously. So there's at least a chance that our solution is going to be consistent with the previous solution. We'll see. And then we're going to have 20x minus 6x, and that isn't going to work out real well. No, we're going to have 20x minus 6x, not minus 20x minus 6x. We're going to have 20x minus 6x, which is this. Now, I don't remember what the numerator was in the previous solution, but I think we might be on track. No, I don't think it's going to work. But again, we get x equals 0, which we reject because it doesn't work in the equation. And when we did this, we either did or should have excluded x equals 0 and y equals 0. So we cross that out. There's no x on the 14. We factored out the x. We end up with negative 31x plus 14. And actually, yeah, the negative is important because that's what was causing me to think we didn't have a solution here. X would then be negative 14 over 31. Okay? Now, if we come back here, and x wouldn't be negative. X is 14 over 31. Okay, in other words, miraculously, and with your help, we ended up with a correct solution. It shouldn't be negative because this is negative. So we end up with exactly the same solution we did before, which justifies the idea that we can either choose to eliminate x, y here and follow our solution, or we can just go ahead and solve for y and plug that solution. Solve the first equation or the second equation for y. Solve one equation for y, plug the result into the other equation. And I kind of think that covers most of the bases of what you're going to encounter.